Hello everyone, welcome back to TechWithAlok. This is session number 6 of our free certified Kubernetes administrative course 2026, where we are learning Kubernetes from beginner to expert. This is completely free of cost. If you are preparing for CKA certification, planning to become a DevOps engineer, cloud engineer, or platform engineer, or simply want a master Kubernetes from scratch, then you are at the right place. In this course, we don't just learn commands, we first understand every concept using simple real-life examples and then move to the hands-on practical demonstrations. If you have not watched the previous sessions, I highly recommend watching them first because every new episodes or new session build upon the previous one. So without wasting any time, let's get started. Okay, now today I am going to ask you a very simple question. Imagine you are working in a company, you have one Docker container. Can you manage it? Of course, you can manage it. Now imagine your company has increased the number of containers and now your company has 10 containers. Can you manage it? But I would say still manageable. Now imagine this is increased to 100 containers. Can you and your team manage these number of containers? I would say this is still manageable. Now imagine this number is increased to 10,000 Docker containers running across hundreds of servers around the world. Who will restart them if any one of the container becomes crashes? Who will scale them during high traffic? Who will distribute user requests? Who will update application without downtime? Can you all do these things manually? Absolutely not. And that is exactly why Kubernetes was created. So in today's session is going to answer one simple question: why does the world need Kubernetes? And we will understand the Kubernetes architecture in very simple way. Let's understand what we learned so far. Let's quickly recap what we have learned so far. In the previous episodes or the previous sessions, we have learned what is Docker, why the Docker was created, and we understood Docker versus virtual machine examples. Then we did the installation of the Docker and we understood the Docker architecture, as I can recall. And in the previous session, the very last previous session, we understood the Docker commands. So today we will move to the next step in our journey, and that next step is Kubernetes. So what happens after Docker? Let's imagine you are building an online shopping application. Initially, you have one web application, one database. So you package your application inside Docker and everything works perfectly. Life is good. Now application becomes popular. Now your application becomes popular. Instead of 100 users, you now have 10 lakh of users. So one Docker container is no longer needed. So one Docker container is no longer enough. So you create more containers. Now you have 5 containers, you could have 10 containers, and you could have 100 containers or 500 containers. Now ask yourself, who is managing all these containers? Who decides where they should run? Who checks if one of them has crashed? Who starts a new container when traffic increases? So Docker is excellent at creating and running containers, but Docker is not designed to manage thousands of containers across multiple machines. So that is where the Kubernetes comes in. Let's understand from the real life example. Imagine you go in a restaurant there is a one customer only and you are the only customer and as of now there's only one chef can prepare the food for you. Now imagine at the same time 500 customers arrive at the same time. Can one chef manage everything? Your answer would be no. You would need a manager, you would need a multiple chefs, you would be needing a waiters, you would be needing a management staff out there in the restaurants, you would be needing a billing staff and the coordinator who usually coordinate with the waiter and the chefs. So you would be needing a kitchen coordinator as well. So the restaurant now has a complete management system. Similarly, Docker creates a container, but Kubernetes manages those set of containers. Now let's understand problem Docker cannot solve. Problems Docker cannot solve. The number one problem is scaling. Let's understand what is scaling first. Imagine it's a Diwali season in India. Your shopping website suddenly receives millions of traffic, millions of visitors, and you are running your application in one container. But that container won't be enough. You would be needing more containers immediately. Can Docker automatically create them? The answer would be no. But the Kubernetes can. So this is an example, or this is the problem that Docker cannot solve. Second problem, self-healing. Suppose one container crashes, user cannot access your application. Who starts it? Docker will wait and it will not restart itself. Then in that case as well, Kubernetes immediately creates a new container. This feature is called self-healing problem. So Docker solve the two problems. One is for the scaling and second is a self-healing. The third problem is a load balancing. So these are the problems that we all discussed in the previous sessions. I am just iterating once so that you can recall all those things. So before going on to the Kubernetes actual sessions. So imagine 1 lakh user visit your website and the traffic becomes increasing day by day. If all requests go to one single container, it will become overloaded, right? So Kubernetes intelligently distribute traffic among multiple containers. So this is another problem that Docker cannot solve. So which is the load balancing. The next problem the Docker cannot solve is rolling updates. Let's understand the rolling updates in a better way. So your application, let's say running with one version, you have built an application, you have developed some features and you are calling that features is with the application and it is running on version 1. Let's say it's the first version of your application. Now you have updated some more features in your application and you want to deploy the latest set of features, and that you will be calling as a version 2. Let's say you want to deploy the version 2. Can you update all the containers without downtime in Docker? No. But with Kubernetes, yes. If updates container, so in Kubernetes, in generally what happens, it updates containers one by one while keeping this application available. Let's understand the fifth problem. I would say high availability. Suppose one server crashes completely, users should still be able to access your application. That problem Docker cannot solve. So this is solved by the Kubernetes. So Kubernetes, what happens if one of the container or one of the pod crashes down, Kubernetes automatically schedule your container to another healthy server. So these are the some set of problems that Docker cannot solve, but the Kubernetes has solved the problems. So let's understand the new one more important term you could be hearing in your interviews, or could be hearing on day-to-day basis when you are discussing up in the Kubernetes. What is container orchestration? Let's understand the container orchestration. So this sounds complicated for you, right? But it is actually very simple. Let's imagine you are conducting a music concert, and there are so many musicians. Everyone plays independently, and in the result, what will happen? By playing their music instruments independently, it becomes noisy. The environment becomes noisy, and the audience cannot listen properly who is playing what and what tune they basically wanted to play. So in that case, the conductor or the person who is managing all those singers or the musicians, he ensures everyone will play together in a correct order. Similarly, container orchestration means managing all the multiple containers automatically, which includes scheduling, rolling updates, scaling, high availability, everything, which is the features of the Kubernetes. It manages everything, and everything would be automated. So this is the meaning of container orchestration. Let's understand the Kubernetes in a simple terms. Now let's define Kubernetes. So whenever you go over the web and you search what is Kubernetes, so you will see a definition like Kubernetes is an open source container orchestration platform that automates deployment, scaling, networking, and management of containerized applications. But if you are a beginner, can you understand these? Let me go and search what is Kubernetes. So it is saying like Kubernetes is also called K8s, is an open source tool that automates the deployment, scaling, and management containerized application. So as a beginner, can you understand this definition? The probably it could be yes, but the people who are very beginning, who are the people who are learning the Kubernetes first time, they might not be able to understand. So just for those who are not able to understand the definition of the Kubernetes, the standard definition that we find over the web, instead of that, you can just understand, or you can just remember this statement: Docker creates containers, whereas the Kubernetes manages those containers. So this means equivalent to the definition, the actual definition that is written over the web. So in the Docker, it only creates the container, whereas the Kubernetes, it manages the containers. That's all you need to remember for now. So now in the next part, let's understand the Kubernetes architecture. Now let's understand how the Kubernetes is built. Whenever someone hears the Kubernetes, they think like it's a software, right? Actually, Kubernetes is not a software. It is made up of multiple components working together. So the architecture, the Kubernetes architecture has two components, or two main parts, I would say. The first part is control plane. And the second part is worker nodes. So Kubernetes originally has two components. One is control plane and the second one is worker nodes. So let me draw in a diagram so that you can understand in a better way. So let's say this is your K8 cluster. I will be writing the Kubernetes in a shorter way, the K8. On the K8 cluster, let me write it as a cluster. On the top of that cluster, we would be having two components. One is control plane and the second one is worker, let's say worker nodes. So let me type as a worker 1 and let me copy and paste it, this one as well. This is worker 2. So this whole set is a worker block. So this is whole set is a worker block and this is the control block. Control plane communicates to the worker node on regular basis. So let me type an arrow here. Let me draw another arrow for worker 2 as well. Now think of this as a company. So the control plane is a management team in a company, whereas the worker nodes are the employees who actually do the work for the company. So let's understand the Kubernetes control plane. So the control plane, just think from that perspective. Control plane is the brain of the Kubernetes. So whenever we want to run any application, the control plane does not run any application on its own. So the control plane, it does not run your application. So what it does in that case, instead of that, it makes decision where your application will be running, where your containers will be running. What happens if pod crashes? What happens if pod crashes? When should pod would be automatically scaled? When we have to scale the application. So everything is controlled by the control plane. So then we understood the meaning of we understood the purpose of the control plane. Then what the worker node does? So worker nodes are those set of machines where your application actually runs. So each worker node has its own pods, own containers, own kubelet, own kubeproxies and container runtime. So we will just forget about those things. We will study these components in the next episodes or the next sessions. For now, just remember, control plane decides and worker node executes. So let me write it here as well. Control plane decides, worker node executes. So let's understand from the real life example. Imagine a school example. The principal decides which teacher teaches which class, the timetable, the school policies, whereas the teachers actually teaches the students. Similarly, control plane is equivalent to the principal, worker nodes equivalent to teachers, and the rest of the components within the worker nodes like pods is equivalent to classrooms. Just forget about the pods as of now, because we will understand its working way and the definitions and how it works in the Kubernetes cluster in a later set of sessions. So for now, I'm just writing it down here. And the containers which are running inside the pods is equivalent to students. So hopefully you have understood the Kubernetes architecture and the components of the Kubernetes architecture. So let's revise everything what we learned today. So today we understood why the Docker is not enough, the problems that we have seen in the Docker, what is the container orchestration, what is Kubernetes, why the companies uses the Kubernetes, and the Kubernetes architecture, which has two components, control plane and the worker nodes. So for now, I will stop myself, and in the next set of sessions we will go more deeper. We will learn about the further subcomponents of the control plane and the worker nodes, like API server, etcd server, scheduler, control manager. So we will understand what each one does with the simple examples of the real world. So at the end, I would say, if you really enjoyed this session and learned something new, please take a second to hit the like button. And if you have any questions, leave them in the comments. I read every comment, and your feedback helps me to improve this course. If you are new to this channel, subscribe to TechWithAlok and press the notification bell so that you don't miss the upcoming sessions. And share this free CKA course with your friends, colleagues, and who are learning the Docker, Kubernetes, or the DevOps. Thank you so much for watching. I am Alok. This is Tech with Alok. And until next time, keep learning, keep growing, and keep practicing. Bye-bye.